Hello, welcome to Brownfields Group 16 from Johannesburg. I am Unathi speaking, and I will take you through this presentation and basically outline what to expect in this project. So firstly, I will go through the project overview, then one of my teammates will go through the code and design and conformance, database management systems, evaluating SQL implementation and data management in web applications, evaluating test execution and database verification in software testing, and then we will go through the goals for Brownfields, and then I will go through some of the tools that we used for this Brownfields project, including the Miro code scene analysis. And then lastly, I will go through 5 successful outcomes that we achieved during this project. So to explain the overview of this project, Brownfields development involves working within an existing code base to modify the design of a system, add functionality, or even remove outdated features. So what we had, we were given an existing code base from Robert Wall's project from previous cohorts, where we had to improve on the code base itself, where we had to remove functionality that requires careful consideration and overall just improve the project from when we first received it. So some of the tools that we got in the project, that we used in the project, were Git and GitLab, where we cloned the repo and where we handled our commits. And then we used Miro to track everything, where we wrote some of our stand-up notes, where we also had work delegations, and we also used code scene analysis to further analyze our code as to what is needed into it and some of the functions that are redundant where they were pointed out. And then we also used Google Meet for our stand-up meetings, and we also used WhatsApp. So to further explain the tools that we used for version control, we used Git to safeguard our source files during our development. And we used version control to help prevent loss of data by tracking changes and allowing us to revert to previous versions if necessary. For in case like when one of maybe our team members would commit something that that affects the code, doesn't work with the code, we would use Git to revert some of those changes and we would improve on that code. So we used Git on this project a lot, and we used GitLab for version control. So to further explain some of the tools that we used code scene analysis to check on our progress of the project and our code health throughout the iterations. We checked where it was pointing out if there's redundant code, where there's too many if statements being used, where we need to refactor code, and where we can improve our overall code health so that the project is healthy and does not conform to like being broken. So now that I've explained the outline of the project and everything, I will hand over to my teammate Jennifer, who will further explain the code and design conformance of our project.
Good day, everyone. My name is Jennifer, and I will be talking about Section B, Code and Design Conformances. So what we will be talking about is how the code runs, the code, the README file, and documentation. So let's get started. First, you can see the multi-server, and this is what the multi-server looks like, and the robot server. When you see the robot server, it will ask you, what would you like to name your robot? We will be naming our robot Hal. So if we type in Hal and press enter, it would ask you, what would you like to do next? So the next thing you have to do is launch your robot, because your robot needs to be launched into a new world and able to do other commands. So when you press the launch command, it will give you it will read information out of the JSON and give it to you, like the repairs that you have, shields, reload, and your position, which is at 0, 0. Now, let's do one of the other commands just to show that we have multiple commands that work. For example, the forward 10. So if you enter forward 10 and enter, you will see that your position changed from 0, 0 to 0, 1, which confirms that you have moved forward by 10, which shows that the program does what it expected and does what the client would expect it to do by forward 10, for example, that it moved forward by 10. So I would think that the expectations of the program is way up to standard. Now if we move to the multi-server, we would see that it shows you that there's a robot connected and the name of the robot and that it launched. It will also show you the commands that the robot does and the name of the robot, like HAL move forward by 10, which is a command that we did. Now, just to show that we have multiple commands that calls data, that reads data from the thing, we're going to run the dump command, which gives you the height, the width, and the robots that's in the world, which shows that we are reading data from the JSON files and displaying it to our client itself so that the client can see the world's dimensions as well as the robot. Now, if we move on to our code, we want to show that we have done efficient testing in our code. Not to just ensure that the code's expectations are met, but to ensure that the client's expectations are met as well, and that our code runs smoothly according to what it's supposed to do. We also did stress testing to make sure that when we launch our program, we don't have to worry about it crashing because we have tested every possible outcome that there is. Now, if we look at our forward command, it shows that our naming conventions are up to standard of what the command does. So forward commands, for example, moves the robot forward. So it shows you that the command does what it's named to do. But even if you look at our characters, message and result, it gives you the message and the result of moving forward. So it gives you the message that it did it and the result of the moving forward, which shows that even our characters are named according to what it is supposed to do and that our naming conventions is up to standards. README. So if you scroll up into the README, it shows you everything that the client would need, like the group people who made the project, the overview of the project, which shows what the project is about and what is covered in the project. If you keep scrolling down, it gives you the folders and the structure and layout of the project so that the user can see what is required. In the to run, it gives you the database, SQL, and API. These are important files which you would need in order for your program to run to the perfect expectations that we need. Acceptance testing, which shows that we didn't just acceptance test against our multi-server, but as well as a reference share to ensure that the project runs smoothly. Lastly, we added our Git repo to ensure that the client can go to the repo and clone so that they can also get a version of the project on their computer and not just ours. Now, if we go back to the forward command, we want to show you that we have proper documentation which shows what this command does, what is required of it, what's inputted into it, so that when the project is handed over to other coders, that they can efficiently read what we did and what they need, how they can add onto it. Even if you look on the left command, we have proper documentation so that other coders can add onto it, but not just coders, people that look at the code, that they know exactly what is going on at what part of the code, which shows that we have efficient documentation and that our code does what is expected of us. Now I'm going to hand over to my teammate to talk about section C. Thank you very much.
Good day, Sita team. My name is Leoni. Today I will be responsible for presenting section C database management system. We made use of SQLite for this implementation, and for the implementation of ORM we also added EOD SQL. So I will now be demonstrating how this actually works. And also another note, for ORM we have the obstacle DAI, the obstacle DAO, world DAI, and world DO. So I will now be demonstrating how this works. First of all, we will be running dbconnect to connect us to the SQL database. So now we'll use our terminal as it is already connected. We will use our terminal and we will connect to SQL. And world robot is the name of our database, world robot.db. So right now we will be checking our tables. We can see that we have obstacles and worlds within our tables. So let's check what obstacles have. We can say select all from obstacles, and you'll see that we have 1 rock, 10 and 20. And then we can also select all from worlds, and we have Leoni, and I did add Sita as well. We can also now run the multi-server. And we can say save Sita world. And one of the problems we do have is adding obstacles through SQL, so that is a bit of a problem. However, we can add it manually, as I will demonstrate that soon. So in worlds, we say that we save Sita world, so let's actually check. Again, select all from worlds. See, we added it. Select all from worlds, and we can see Sita world has been added to our worlds. So this is also just an overview of how our code looks, how we implemented EOD SQL into our code. So as you can see, we have added it. However, we still use JDBC. However, with the selection process of SQL, we found it easier to just use EOD SQL for the ORM purposes, which makes things so much easier and so much more structured. And I did also mention the database connect, obstacles DAI, the obstacles DAO. So this is the obstacles DAI implemented, obstacle DAO, and then we have world DAI, as well as the world DO. Thank you so much for watching my video. I am truly grateful, and I hope you love this. Thank you.
This is the Java server and sets up the API endpoints. In this case, we have 3 endpoints. One for get request for default world configuration, the current world. The second one for specified world configuration, which is handled by this class handle class, which takes the context. Then the third one, it's for post request endpoint, which sends commands to a specific robot by its name. So this is the class that handles the endpoints. The first one handles the get request to retrieve the default world configuration. This includes the world's name, height, width, and obstacles. which takes a parameter, which is the Javelin HTTP context for the request, providing access to the request and response. The second one handles the GET request to retrieve a saved world configuration from the database. The world is restored based on the name provided in the URL path parameter, which also takes a Javelin HTTP context for the request as a parameter. As here it tries to form a connection to the world robot database with the world name to get the world name specified. And here I'm creating creates a JSON object with world name, height, width, and its obstacles and positions and sizes. The third post request is for executing commands on a robot. The robot's name, command, and arguments are extracted from the JSON payload. The command is then executed, and then the response is sent back to the client, which also takes the Javelin HTTP context as a parameter. Here it sets the context status to 200, and I'm using JSON node to make the response readable from the terminal when I'm using cal. So back to our SQL database. The restore world and its obstacles from the database by loading the world parameters and obstacles based on the world name, which takes the parameter world name from the connection object to the database and throws SQL exception if a database access error occurs. If it doesn't find the world name on the database, it throws a runtime exception, world not found, else it sets the world parameters to the restored world. Successfully will be restored. On to the method that creates tables. It creates the necessary table for worlds and obstacles if they do not exist. World table stores world data, the ID, name, width, and height, and the other one for obstacles stores obstacles data, ID, world ID, foreign key to worlds, then their type, obstacles type, and their position and sizes. Save the world. The method save world. It saves the world and its associated obstacles to the database. If the world already exists, it updates the obstacles for the existing world, which then takes these parameters: world name, width, height, obstacle, and throws SQL exception. On to our server API. Going to rerun our API using Javelin on port 7000. For this, we'll be using postman. So we can get our default world name, world, which is the current world. We indeed get our world response body as a JSON with the world name, obstacles. Currently there's none, with width 100 by 100. Then we check our database, SQLite Tray World Robot Database. Select all from world. which now our database has these world names, robot world, test 1, test 2, and so on. So in this demonstration, we're going to be getting this robot world with ID 3 from our postman. So it's robot worlds which is still a get request. As you can see, the world name is robot world name with obstacles and their positions and sizes. The width is 200, height 200 as our database has 200 and 400. And also if you try to get the world Jennifer, with capital letter J. We do get the whole name Jennifer with width of 100 and height of 100 as our database said, 100 by 100. Then if you send a post request, I'm gonna use Kganya. When we launching as a normal robot. We do get a valid response from our API with the feedback result okay, and our data, the robot is Kganya as specified with the configurations I made 5 and 5 on this position facing north. And we can also go forward 5 steps. We get a valid response from our API with the result okay and message done. And we moved 5 steps, and also we can move 10 steps again, and we'll update our position to 15, and we can turn right, turn right. Now we facing east, and we can get our robot state. With no argument, we get our robot state still facing east, and 15 steps. And we can also go back 15 steps. We did go back 15 steps. We can also send a GET request using cal. We can get world
which it does return world in our database, which is this one, ID 18 with the width 100 and height 100. And let's try to get test 1. We do get test 1 with the obstacle on 210 with 200 and 400 as our database said. You can also send a GEL request, post request with the same name I was using on Postman, with the content type set to application to JSON, and I'm still using the robot Kganya.
My name is Nao Matala, and I'll be going through section E, evaluating test execution and database verification in software testing. Right. So we utilized two testing types, namely unit tests and acceptance tests. So acceptance tests are tests that evaluate they evaluate if a system's software functionality and performance, to test if it meets the specified requirements. So basically, the output, if we get the expected output, or acceptance testing is more output based, unit testing is more outcome based. So essentially what a unit test will do is it'll gauge, or it's responsible for testing if a block of code, an isolated block of code, essentially operates the way it should, meaning that the essential steps are taken to come to a specific outcome. That's the difference between the two tests. So for now, I'm going to run you through an example from our code of an acceptance test and how we utilized it operationally. Right? So operationally, what we'd do is make a story, or have a scenario, make a story for it on our GitLab, on our repo, actually. On our repo, under, in our issue boards. So sequentially what would happen is you have a scenario, write a story for that scenario, and then write an acceptance test as such. So we're going to look at this one where we look into the world, right? So given that I'm connected to a running robot world server, because I need to be, the server needs to be run, first, so that I can connect, I launch my robot named Hal, and I want to look. So as soon as I look, Hal needs to find all of the obstacles in the world, right? So the input data would be look, and the expected outcome would be for it to look, right? So a deviation or something that didn't go to plan with this particular one was, what essentially happened is we'd look, and because our world wasn't generating any functions, it would look and not find anything, no matter what we did. So we had to adjust the code to add obstacles, and eventually it worked out just fine. So our standards and procedures were as such. So what happened is all testing procedures were carried out in compliance with our test plan, meaning we'd have to write the tests, write the scenarios, or the stories rather, and then make tests. Retesting was done in cases as I just mentioned, where there was an initial failure due to the code not being correct, logic parts and error elimination. So what we're going to do is look at some of our command tests, and where we account for something like that is this particular one where an invalid command should be null. So say for some reason you think, I want my robot to jump. There's no functionality to support that particular for that particular function. So essentially what's going to happen is it's going to go, it's going to go, the test is invalid, right? Another example where we do this is we account for human error, where you make a mistake and spell, we're human, we make mistakes, where we spell one of the commands wrong. So say you want to go forward 101 steps, but you spell forward wrong. What it's going to go is it's supposed to return an error and tell you that that's an unsupported command. So what we're going to do now is look at some of our SQL errors and how we manage to mitigate that as much as possible. So we're going to look at the obstacle DO test. So essentially what happens is we make sure in our unit tests that the right places are cited to obtain the right kind of obstacle. For instance, say you want a square obstacle, right? We only have support for square, we only have support for a mine obstacle. Right? So it can only be set to those particular ones and nothing else. And then a test to verify our database. So our database access was thoroughly tested in the production environment, and we ensured that all functions performed as expected under realistic conditions. Right. So essentially, that's what most of these tests do. So we're gonna take a look at the get world test here in our API as an example. It goes specifically, so that's the port number and everything. So we need to make sure that we get the right world, namely robot world, and world name. So we essentially make sure that you have to add a width and a height. If you do not get a width or a height, it's going to tell you that the world cannot be null. Performance according to requirements. So essentially some of our requirements were in our criteria that's necessary for our requirements. The requirements necessary or stated in our criteria were that a world needs to be saved with a height and a width and obstacles as well. So essentially this is by default, right? This is the setting for default, and this is how we get the specific one. So for example, you named your world JJJ, and as such that's your world name, and we're going to get the width and the height, both of which cannot be null. Functional verification. All of our databases functions were verified against the functional requirements, with particular focus on data retrieval, insertion, and update operations, which I did highlight before. Also our test detailed that records were maintained documenting each test case, input data, expected results, and actual outcomes. So again, in the world JJJ, We're expecting JJJ being the world name. This particular function gets the height that you set and the height, right? So essentially, that one was a get and this is a post. So what the post essentially does is it'll return or post onto our web address the essentially everything about your robot. So the robot name would be Kganya in this particular example, and the command would be launch, and the arguments, whatever command set. For this particular one, it would be launch, and it'll return a normal robot with shield strength of 5 and the max number of shots being 5 as well. So the results are systematically recorded in the test management tool, allowing for easy review, analysis, development, and quality assurance team. So essentially, I think we did go over that in the sense that the content will be posted exactly how you put it. It also checks if the right type is added as well. So the improvements that we could have made was maybe be more thorough unit tests, being very specific on a block by block basis. And the tests were wrote to be as scalable as possible. So should any functionality be added, not to you wouldn't have to write too many new test bases. You just edit the ones that already exist. So we did review the tests. We had a very strict review of tests. We had to make sure that they pass and they tested the right things, and you could explain exactly what was tested. That was me. Thank you.
Hello again. So I'll be closing off the presentation, but first I'll talk about the goals for brownfields. So we had acceptance tests that we needed to make sure were running against our server and the reference server that we were provided with. We had build scripts that we had to implement on our own. We had the pipeline that we had to make sure was passing all the stages that we have implemented. We had Docker, where we had to create an image and a container, and we had to add it to the pipeline as well. We had the database and the SQL. We had code analysis that we had to monitor each and every time, just to make sure that our code health was improving and not declining. And then we had the web API and object relational mapping. So with the goals that we had, at the end of the project, we had 5 successful outcomes. One of them was that we went from not knowing anything about APIs to having a functioning API. 2 was that we went from a basic understanding of databases, but now can successfully save and restore a database. 3, overcoming both personal and team-based challenges to ultimately finish our project. 4, working well together. And the last one was overall understanding of brownfields. We went into this project not knowing much about brownfields, but towards the end we knew what we wanted, and we managed to achieve a lot more than we thought we would achieve. So with that being said, thank you for watching our presentation, and have a good day.